it.
Okay, let's look at 64 then. I was looking at it right now. So it says that, I'll start here. JTR roofing charges 300 for the first hour. Now this is cost. They normally use the capital C, and you can do C of X, but since this is relating to hours, if you want to be pretty grammatical, like, you would do C of T. Is that okay? C of T.
Okay.
And the first hour, it's 300 fixed. So you start with 300 right away. But then here's where the continuation of the function has to be written. This is where it can get tricky. And then $200 per hour for any portion of the job that goes more than 1 hour. Now, this is very typical in algebra. So you have to kind of like memorize it. At first, it might be, it might come back, what I mean is, it will make sense later on. So this is how it's going to be written, just like that every single time. That's it. So, and then it will make sense when you start answering the question. You'll see. So if you like, just go ahead and memorize this, just like that, right off the bat. So this is the setup for the whole scenario for you to answer number 64, 65, and 66. Yeah.
Okay.
Well, actually, I wrote the 67. Whatever. Okay, so the 67 would be this. So, okay, is that okay? Yes. I already,
Yep.
because you can't really, look, I see what they're trying to do here. They're actually have you make sense one by one, but no matter what, you have to come down to writing the function. Therefore, might as well set it up and use it. It'll be done. It'll be so much better. Trust me. I would go with that. So it's 67 would be it. Okay. So never mind. Yeah, pretend you did 67. Okay, now back 64. First hour, easy. If you plug it in, t being equals 1, you can actually write t equals 1. Therefore, c of t, or you can say it. I'm sorry. Let's make it grammatical. Let's do c of 1. Is that okay? Because that's what the function is. You know what? You can't do that because the order is made. But pretend sometimes they make you do the equation first. Therefore, you have to write the whole c of 1. But this one,
Okay.
you don't have to write c of 1, but you have to make sure t equals 1. Therefore, your function will be left with just 300. You see that? So this whole thing will go to 0. Therefore, you're left with 300. If you want, if you want, just write $300 because they think that you actually didn't write the function yet. So say $300 is basically when your first hour starts. It says right there. See it? Right there. 300 for the first hour.
Oh.
So they're anticipating you don't write the function yet. The actual function yet. So yeah. So it's 300. So don't worry. Okay. 65. If the job takes 2 hours, now is where you'll have to actually consider the 200. So 200 starts basically. If you plug it in, you get the answer right away. By the way, okay. If you want,
so
it'll be 500. It'll be 500 exactly. So if you want to make sense of it, you can. What 300 no matter what. So let me write it like the way that your teacher made or the way they want you to for the instruction based on the instruction. So it'll be written like this: 300 plus 200 times. Let me see. 200 per hour for any portion of the job more than 1 hour. See, more than 1 hour. That means it says 2. Immediately, it's just 200. Think about that if you want, okay? But the cheating will happen right here. If you want to memorize the form, you can plug it in. It will be 200. 3 plus 300. So it's 500. Is that okay? If you didn't write the function, you still can make sense of it. It said, hey, 300 no matter what, then 200 per hour for any portion of the job that goes more than 1 hour. Therefore, you went 2. Immediately, it's $200 extra. That's why. 500. Now, for 40 hours. So, passing 1 hour, that means you pass 40 hours. I mean, you went 40 hours. You pass it by 1 hour. That means it's 39. But if you don't want, plug it in here. Just plug it in there. Is that okay? So 39, 39 times 200. Let me use the calculator. Whatever that is.
No, wait. Yeah, just 200
times
is
200.
7 something something.
Yes, that's right. 7,
7, 8.
7,
7,800.
7,800. Okay. So it's going to be 300 plus 7,800. But you want to kind of show the work a little bit. 200 times 39. I'll double check on that, but I'm sure it's right. Okay. And what is that? It's going to be, don't forget, that's many hours you've done. It's all in dollars, okay? But we'll put the dollars in after. So it's going to be $81,000. $8,100, sorry.
Okay.
So that should do it for this problem.
Yeah.
But it's a little tricky if you try to make sense of it verbatim before you write the function. That's my opinion. But
I would
yeah,
probably just write the
yes,
formula first either way.
if you memorize it, it's standard. This has been documented. If you want, the wording is exactly it's common in based off also cell phone plans and all that. This is actually pretty much the stepping stone of that. So it's like they based everything off this particular one. Okay, continue on. I'm pretty sure. Okay. Oh yeah, don't forget to write your cost function here. Okay, so that's that right there. Okay, so this one, it's not bad because they gave you the function, but you have to interpret how to use it, right? So they gave you the height function based on this scenario. It's basically they're launching. I don't even read this. I don't want to read it, but I look at the parabola function. I know immediately it's very again common. Oops, I got my ink and white again. Okay. So when the rocket reaches the maximum height, so this is a parabola. If you know recognize it, it's like an upside down one because of a negative in front. So that means since it's a parabola, doesn't matter if it starts somewhere. It does start at 400, by the way. If you look at if you're familiar with the form, it's not just like hey from the ground. It's from at 400. I don't know, from a building or whatever.
Okay.
Here it is. See,
Oh
I
yeah,
told
I
you I didn't
remember
read. I
doing
told you I did
this.
not read this. I told you I did not read it. I can tell by looking at it. So it says initial height. So you're on a building and you shoot the rocket up at 400
No,
feet
I remember
from the
this. It's
building.
like where it's like
Yep.
it's in a problem, but it is like a parabola if you like
Yeah.
think about it like that.
Yep. Exactly. So no matter when you do a max at height, you always use that formula, negative b over 2a, that vertex formula, because remember the butt end of the parabola, the x coordinate of it is negative b over 2a. So that's why you always use it. So
Okay.
use that, but then you don't forget your a is negative 16, your b, and your c. If you need it, you don't need c. But let's plug it in
Oh.
quickly. Oh, it's X, okay, but it's T. We use T, but you can keep the X form because that's what everyone uses. So like negative B, so it's going to be negative. I'm sorry, negative fraction, but let me put a negative in front. Negative 20. The numerator is 20, and then 2 times negative 16. It'll be positive in the end. So what is that? It's going to, I'll do a fancy math here. 2 can go into 20, 10 times itself one time. Negative cancel with a negative. Therefore, you're left with 10 over 16. But then reduce that 5/8. Okay, whatever. Then use that and plug it back into the height function. So you're going to do h of 5/8. I don't like it, but don't forget, this is actually word problems. You have to kind of deal with it. Negative 16 times 5/8.
No, I
Now,
remember one of the when we were studying this right before the test last
mhm,
time.
uh-huh.
I got like a bunch of random decimals that I was like, this there's no shot this is right. This is horrible. And it was right. And I was
But
like,
it's
how
right.
is this
Yeah,
right? It's a
it's
whole
right.
bunch of
Yes.
decimals.
Yeah, so this is actually based off physics problem, meaning that the answers they never actually have everything come out evenly like nice numbers.
Mm-hmm.
It's always decimal. Yeah, so I actually would use a calculator for this whole thing. Is that
We get
okay?
calculators on the test,
Okay,
so.
great. Yeah, 5/8. I would not round the 5/8 though. If it's I don't even know what if I punch in what it looks like. Yeah, don't round the 5/8. If you at any time you want to round something, round the 4 decimal places. That's physics. Yeah, you know what?
Oh,
You can use it. You can use it because but you got to use the whole decimal places. You got to use exactly 0.625 if you want to. Okay.
oh,
Yeah, but you could actually
okay.
go ahead and write 5/8. In your work, like show you plug in 5/8. But then when you punch in, you can do 0.625, 400 here.
So for the final, I don't know if I'll need it for this specific, like for the word problems, but we get to use a note card,
No card.
like on the final with
Okay.
handwritten notes on it.
Okay.
So if I do need that, or if you think I need something, I can write something down.
Yes. Uh,
I don't know,
if
just
I were you, I
checking.
would write the number 64 down. Hey, I made a mistake here.
Okay.
Yeah, I write the form 64, and write this little phrase here, like some number per hour for any portion of the job that goes more. This can be worded differently, but the more than 1 hour happens when start more than 1 hour. I think I would recommend you write that. But the number has to go here. The 200 goes in front, parenthesis x minus 1. Is that okay? Yeah,
Okay.
that number. But you'll always have fixed value. I don't know how they're going to word that. You start with some number, so that's the starting number, 300 right there. Is that okay? Hey, I made a mistake for this problem. It's not 20, it's 200. That's why it's weird 5/8. So let me back it. Sorry. You see that? The B is not 20. I went like this and I covered the zero. Sorry, dude. Oh, I'm just so lame.
Wait.
I circled 200. I covered the zero and I thought it was 20.
Oh,
It's just so lame. So it's 200 for B. Is that okay? So negative B, which is 200 over 2 times negative A. So 2 can go into 200, 100 times. And then now the number come up nicer. I already know because I punch in 10 divided by, well, I punch in 5/8, but let me punch in, I'm pretty sure. It's 6.25, I'm pretty sure. But let me do it again. So 100 divided by 16. Yeah, 6.25. So now you can literally use that number for t instead. Positive because the negative cancel.
okay.
So
Yeah.
now you can
That makes
plug in
more
nicely. So you have to
sense.
deal with fractions. So yeah, go
Okay.
and use t, plug that in to the height notation they gave you, height function. So 6.25 squared plus 200 times 6.25 plus 400, whatever this is. Pretty sure. I'll punch it in if you want. I mean, I can even use the graphing. I can even graph it. It would be perfect too. Squared plus 200 times 6.25 plus 400. So it'll be 1,000. It seems right. Yeah, as long as it's not come out like weird small number or anything. 1,025. Double check that. I forgot. Yeah, 1,025 feet. Yeah, plug that in, and that should be it. I'll put a comma here to make it
Sorry, I'm rewriting the problem. I wrote all the stuff down before we did the 200 thing.
okay. So you got it?
Sorry.
No worries, you got it?
Uh,
So yeah, yes. So you plug in the B, 200, 2 times A, 2 times negative 16, negative cancel. Then I did a 2 go into 200, 100 times. So I'm just left with a 100 divided by 16. But you can punch the whole thing in however you want to get your T or your X. Negative B
okay.
over to A. Yeah. So I got my 6 point. Yeah, do the math however you want. It's going to be 200 over 2 times negative 16, but it's negative, okay? Negative B, negative, cancel.
Okay.
You get that, okay?
Yeah, I get that.
Yeah, and then you do h of 6.25. and then punch in the calculator.
Okay.
So what I got is 1025. Seems right to me. Yeah, pretty sure. And then we're gonna do max height here. What will be the maximum height? Oh, sorry. I
Oh,
went
so
ahead.
sorry.
So it says when, okay, for 68,
Oh.
this is the answer is 68. This is 68 when the time is at 6.25 seconds. Okay.
Oh, so we solved ahead. That's cool.
And then 69 is when you plug it in, already did. So here it is. 69 will be 10,025 max height.
Okay.
Yeah. Your 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 x equals
Yeah,
negative b
yeah,
over 2a, right? It's your x coordinate where the highest point is. This is your x or your t in this case, right here, the parabola. So this is your x equals negative b over 2a right here.
okay.
But then when you plug that x or t back into the height function, you'll get your max height, which is the y value.
Mm-hmm.
So the max height is 1025. So that's your 69.
So for number what number is that? 70? I think there's just maximum of four on
Yeah,
there.
they print that wrong? Yeah, they did,
But
huh?
can't we just double the 1025? Like, isn't
Wait,
that
okay. I think you meant
or
double the time,
or
not the
times?
feet.
Yeah.
Yes, you can
Yeah,
double that. Yes. How many seconds? What? Yes, because it's parab. Oh, wait a minute. We cannot do that. Sorry.
yeah.
Here's why. Here's why you cannot do that for this one. Because you
Okay.
start off, if you look at the picture, right, if you were to draw it, it's not symmetrical because you start off at the height of 400. So you see it's cut off in the first quadrant. Look, let me draw the first quadrant again. You cut off, it's no
Oh,
longer,
it's like
it's no,
one.
yeah, it's no
Okay.
longer half and half. You see that? There it is. So you
Yeah.
cannot do that. Yeah, sorry. But yeah, you had the right idea. You remember this problem, right? From like a batting, I think it's like a
Kind of,
batting problem.
yeah.
Yeah. So I think someone batted from the ground or a golf problem. You hit it from the ground. Yeah, that's it. It's the golf problem. You hit it from the ground and then
Something
it
like
lands.
that.
Yes. Okay, so yes, there are problems like that. But if they start off at a particular height, which is this back number here, you cannot do that. So you have to
Okay.
actually set
Okay.
it equal to zero. And guess what? You have to use a quadratic formula. You have no choice. I'll let you do that. Well, I'll use Wolfram if you want, but here's the setup. Yeah, unfortunately, you cannot do it. But you got the right idea, but look for, yeah, if you come across the problem that has to do with hitting it from the ground, yes, then for sure, yes, not this one. Okay, yeah, I see what you're thinking. So this is what you're gonna do,
Yeah.
but then you gotta do your quadratic formula. So don't forget, this is your A, your B, and your C. So you can punch this in later if you want, okay, but I want to move on, but
Okay.
I'm 100% sure, but let me show you the setup here. Yeah, negative b. Yeah, negative b is going to be negative 200 plus or minus a root of b squared, which is 200 squared minus 4 times a, negative 16. It will be positive inside, perfect, times c, which is 400 here. Underneath all this, underneath the root, all over 2 times negative 16. It will cancel. If you punch in, you're going to get two answers coming out of it. You pick the one that is positive. So it's
Okay.
going to be 2 times 16 here. It'll cancel out and make one of them positive. So there it is. So whatever the t is, we'll come back and plug in if you like. But yeah,
Okay.
only choose the one that is positive. If
Yeah, I can solve that later as long
yes,
as I have the formula.
okay, good. All right. Okay, now tell me where should we
Uh,
continue?
let me. Oh, the next page. I don't know if it is the next page for you, but 74 through 80. I think it's the page right below and to the right.
Below to the right, this
So
one.
yeah,
Okay.
or the one next to the right of it.
What do you mean this one?
Or wait, what am I saying? Hold on. Uh, how do I explain this?
What number? I think
So
I can find it.
it's 74 through 80.
74 through 80. Unless I didn't bring it in, but I'm sure I.
It's the one with like a bunch of graphs without
Okay,
any
this
like
one right here, right?
labels.
Yes, yes,
Yeah.
yeah. All right.
I always have trouble writing the equations for graphs. I never
Yeah.
know how to do it.
Yes. Because you have to actually recall the parent function of each. That's why.
Mhm.
So I'll write the parent function right away. This is the cubic function. Therefore, the parent function of the cubic function is f of x. Well, I'll do y. Let me write y to make it simple. Y equals x to the third. But 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 there's more to it than that. This parent function looks like this. It's actually increasing. If you notice, this one is decreasing. Therefore,
Okay.
it's a negative. So it's a negative
Okay.
right away. But then there's more to it because this is curvy. If you notice, the parent function is not, it does not like contain the max and min like this. You see, if I were to there's a maximum, minimum. This one has none. It's just like parent. So it's like bare bone. I think you can say it that way. But you still have to make it a third power. So okay. So when you do 74, the characteristic of it will be a negative x to the third function wise. Y equals negative x to the third, and something in the end. That's all. But then
Okay.
let's do the something here. So it'll be a negative because it's decreasing, but if it's positive, it will
Yep.
go something like this. Is that okay?
Yeah.
If it's
Like
positive,
the wait, no.
like
I
the
don't know.
parent.
There's no example.
Yes. Okay.
Whatever.
Or like the parent, but yeah, they're not going to give you the
Yeah.
parent. It's too easy. So to do this, you're gonna have to recall more concept. Remember when it touches the axis, it's bounce. When
Yes.
it crosses through, it's basic. Oh, bounce is second power. Remember, it's a second power.
And
This is
go
a first
through
power. It go through first
normal.
power. So I'll write it like that, parenthesis. But then when we put it together, it will look like this. Here we go. It'll be a negative. Oh, there's more to it. It seems like your teacher wanted very thorough. That means you will actually have to find like a point that you know for sure, not x-intercept though. Y-intercept is okay. So y-intercept is going to be the point we're going to use. So keep in mind, this is going to be a point to use other than x and y-intercept. So the point is going to be 0, comma 9. That means
Okay.
x, y. So we'll wait on that. So how do we put it together? Well, it's going to be negative a parenthesis like this. Let's see you remember. Third power. Yeah, something like that. You have to find the intercepts to fill in. I'll do the first one, but you do it opposite. Okay, it'll be
Okay.
if x equals 2, then you do x minus 2 here. Then you need to find two more intercepts. Remember, this is a third power, and there's only one more intercept or touches. Intercept and touches are the same, but it bounced.
Okay.
Yeah, it still go through. It still go through the
So is
x
that
axis.
x plus 2 squared?
That's it. That will give you the third power. So that means you don't need that one. Yep. X. What is that one? Plus 2. You mean, right? Is that right?
Yeah.
Yes. Opposite there. Yeah. Opposite here to second power. That's it. But then you're almost done. You need to solve for the a. Sometimes you use p, but it's always remember a all the time. So you have to solve for the coefficient. To do that, you have to actually plug in your x comma y, a point that you know for sure on the curve, other than x intercepts,
Okay.
because you did the intercepts here
Okay.
already. So we're going to use y being 0. So this is y. Oh, I'm sorry, y being 9. Sorry, y being 9, negative a, x being 0. You get this? I'm using this point here to solve for a.
Okay.
Now,
Yeah.
I, I may be wrong here with the negative being there, because if you solve it, if it gives you negative automatically, then that's the answer. Just be careful on that one. I'm laying it out because we know it has to be negative. So anticipate it to be
Yeah.
negative. If it's positive, then put a negative in no matter what. How about that? Is that
Okay.
okay? So let's see what happens here. So I think I'm wrong writing it negative in the beginning, but
Uh,
anticipate it to be negative. Is that okay? So
I have
solve for
the
A.
answer key. I don't know if that'll
Oh, okay,
help, but
okay, sure if you want, but let's solve it just now. Okay, so we're gonna get a times negative 4, because negative 2 times 2. See, yeah, it's automatically generated. You see that? Yeah. So don't write,
yeah.
don't put your own negative in there. So a will be negative 9/4. You can check the answer if you want. Then you put it back in here and you're done. The final answer will be y equals negative 9/4 parenthesis x minus 2, x plus 2 squared. Whichever one first, doesn't matter. So something like that. They might actually foil it or expand it all out. I don't know.
We usually don't.
Okay. So I'm pretty confident. Now, even if the answer looks a little different, I mean, as far as the coefficient is concerned, yeah, it might be different here. Don't worry. Your teacher will accept it because you point
Okay.
out what you wanted to use, the point. Because remember, we did some problems before, we couldn't find the actual point. Like, what about if they use that one? We don't know. We don't know for sure.
Yeah.
So the number will be close to the answer. Is that okay?
Okay.
The coefficient.
Yeah.
So I'm like 100% sure this one is fine. Your teacher will let it. Okay, now 75. Okay, 75. So okay, this one is going to be y equals to x to the fourth power plus something something, and it's positive. Oh, negative. So it's negative. If it's positive, it'll be a W shape. If it's negative, it's an M shape. So I'll write a note on that. M shape, negative. W shape, like, concave up like that would be a positive coefficient, positive function. You could think the whole thing being positive, but I'll even write it to look like that. So here, a negative x to the fourth power, something something. Now, if you wonder what x to the third power, negative x to the third power, something something, it's when you multiply all this out, right? I'm sorry, right here. It will
Yep.
give you that, it will give you that negative x to the third power with
Oh.
some kind of
Okay.
coefficient in the front. So I'm sorry. Make sure that it's not -1. It's negative number in the front. Sorry. Let's put that
Okay.
-1 in the front. Negative. I'm sorry. Negative number in the front. Negative number in the front.
Okay.
Negative number in the front. Because the number for this the negative 9/4 is that number for the function 74, number 74. Anyway, continue here. Okay, so again, let's gather the
So
information
it's like the pass
here.
through,
Yes.
and then
So
it hits 0, 0.
yes. So it would be y equals to a. You need to solve for that a. Let me squeeze in a little bit. Y equals a. Let's go from left to right. What is that? First one is that 5? -5? Looks like it.
Yeah, it's
Yeah.
-5.
So
So
therefore
it's
it'd be +5,
x plus 5.
and it goes through therefore to the first power. And
It's
then this bounces is 0. So if you wonder how to do 0, it's x. Okay, x plus minus 0 doesn't matter. It's just x to the second power,
okay.
and then
It's
4.
1, 2.
So it'll be x
I
minus
think so.
4.
Yeah.
Okay, and that goes through, and that's it. Now you can clean up, or you just go ahead and deal with it or use it. I'll clean up a little bit. It'll be ax squared, x plus 5, x minus
Oh.
4. Kind of organize it a little bit. Now solve for a. To solve for a, you have to look for a point that you know for sure is on the line, other than the
So,
intercepts. Yes,
in that step, did you just simplify it essentially? Like, did you take out the x
I,
squared
I,
and just
I
attach to the a?
are you okay with the x squared being the 0 one? Is that okay?
Yeah, yeah, yeah.
So
No,
what I
I'm
did is
just
that I
wondering
basically
if it
take out the
added.
parenthesis and I made it x squared, and then I commutatively switch them and put it in the front here.
Okay.
Multiplication, you can switch them wherever you want to. It's yeah. Is that
Okay.
okay?
Yep.
So from here though, this is where I was saying earlier that 9/4 could be different. It depends on what point you're gonna pick. See, this proved my point. Where is a point on this curve that you think it's right? That you know for sure that go
Um,
see? That's what I'm saying. That's why the answer. Now if you wonder what about what's up with the solution, right? Well, they computerize that. They generate this graph. They use they first generate the graph. I'm sorry, generate the function, and then they come up with the graph. Think about that for a second. The computer made up the function before before it's printed. Therefore, the A is already made up. So this time you have to look for it on your own. But so I can't even find one. That means you have to come up one and approximate. You see it?
it kind of looks like there's one at -1, 2.
You mean like right here?
Yeah.
-1 comma 2? Yeah, I'll take that one because the other one, I'll take it. But this is where I was thinking and I was
Because
saying,
initially I just looked at it and I was like, oh
okay,
yeah, it's definitely there. But then you zoomed in and I was like, oh wait, it's not perfect. It's very
yeah. So
yeah.
I would take it, or unless you want to take another one. Now, careful, look at this one here. You might think this is the best one. Here's why it's not. Because when you are dealing with a parabola, it will never bend in like that and curve in like that. It's always going to be smooth. So this is actually exaggerated. So it's wrong.
Uh,
It's wrong. So it's never going to bend in
okay.
and come out like that ever. So it's always going to look something like this. If I were to make a graph of this one, it will look just perfect, perfect like curve. There's no bend in anywhere. So careful on that.
Okay.
So this one is exact, is I don't know, it's printed weird. I can't really tell. Maybe the paper. Maybe it has to do with the paper.
Well, I think they took a screenshot of another test that they had or something, and then just put it in here.
Sure.
That's why it's
Yeah.
like a different
I think
border
that.
color.
Yeah. I think that may be maybe it. So what do you think? What point do you want to pick? That
I don't know. I guess the negative
that.
one
Okay.
too.
Let's do it. Let's do negative one too. So we're gonna use negative one, positive two for x and y that you're gonna plug in. So to solve for a. So now you see why the a can be different. Yeah, but your teacher will be fine with it, no problem, because you point out what you're
Yeah.
using. So don't worry. Okay, so leave the a alone. Oh, substitute x and y, leave the a alone. The y will be 2, the a stay a, x will be negative 1 squared, negative 1 plus 5, negative 1 minus 4. Okay, let's see, continue. 2, a times negative 1 squared is just 1, so I'll just leave it alone. A times 4 times negative 5. So it'll be a times negative 20, and then 2 over here. So a will be, as you can see, the a is negative. I was saying that, hey, it's concave, M shape, concave down. So it's going to be negative 1/10 if you reduce 2 over 20. So there it is. And go ahead and plug it back in here for the final answer. So your y
Okay.
equals to negative 1 over 10 x squared, x plus 5, x minus 4. Yeah, everyone will get their a, the coefficient of the function different. That's exactly
That
what I
seems
expected.
right.
Yeah, so let's go with that. Okay, that's done.
So 76 kind of looks like what we covered last time we
Yes,
met.
yes, it's based
And
off.
isn't that easier then? Because like
Yes,
didn't you
it is easier. This one is actually very easy. However,
So this was on the test that I had today, and
oh, okay,
I didn't directly know how to do it, but I gave it my best guess.
okay, yeah. So your HK is here. See that? It's shifted.
Yes, I remember that.
Mhm. And one more thing though, the parent function, it's actually faced this way. That means it's
Mhm.
positive. This one is negative. This function is negative.
Okay.
Yeah. So if you were to put it all together, if you recall the HK, let me go ahead and throw in a negative right here, lingering here. So you know it's going to be negative. Let me put it in front of the fraction here. Okay, this one. If you recall the box thing, it's exactly 1. Could you see it?
hmm
Yeah,
Yeah,
so it's
I was
1.
using that. So
So this one it'll be
something I
1.
noticed,
Yes.
something
So
I
you
noticed during the test is everyone else learned how to do like the parent
yeah.
function chart thing, and
Mhm.
they spent like
Mhm.
30
Mhm.
minutes
Mhm.
of
Mhm.
like the entire class period
Yeah.
doing that, and
I
I
know.
finished the test before half the class even
Mhm.
moved
Mhm.
on to the
Yeah,
next
they
page.
I know, I know. Man, that's why I never actually like that. It's yeah, the teacher has to do better at accepting. I'm sure your teacher, the ones that's flexible, will allow you to do this in
Oh, she's
pre-cal.
pretty flexible.
Good. I'm glad. I'm hoping she also teaches pre-calculus because most pre-calculus student will allow you not to do the transformation table because there's so much concept going on. Just like this one right now, like you're pretty much having a lot and the teacher will let you go by with it. And actually, sometimes they don't even teach it. They actually just tell you, "Hey, here's how it's gonna look," just like that. No secondary table ever. So some teacher,
No, I'm
from
really glad you taught me that because I
okay,
was
good, good,
like for a while I was super duper confused about
good,
that,
good,
and
good,
I learned that I was like, oh, that's actually really easy. I don't know why I was so worried about that.
good, good. But I want to keep you on track here. If it were 2, then it will have to look like this. But you have to use your imagination. It will go through the point like that. You see it? Is that okay? Like that. If it were it were 2, not 1, you have to stack 2 blocks overlapping each other. You see that? If the coefficient, I'm talking the number, the top number here were a 2, then it would be like that. If it were a 3, look for the sorry, this is not the origin necessarily. It has to be the HK. Is that okay? That's your HK.
Yes.
So if it were 3, then it might be something like this, stacked up. Like you can find it. You can look at the grid. You'll be able to identify it. So if it were 3, it will overlap like this.
Okay.
And then it will go through the corner of the box right there. If it were 3. Yep. So it's gonna fall either 1, 2, or 3. But yeah, be ready for that. This one is 1 and it's negative because the way it's faced. Now the HK, here we go.
Okay.
The H, don't forget, is immediately next to the X. The H is immediately next to the X. So the H is it's a negative 3, but you always do the opposite. Only then
Positive 3.
positive 3. But the K will always be as is. So it's plus 4, done. And this is the function. You can do f of x if you want, but y is acceptable.
Okay. Yep.
4, yeah, it's 4. Okay. Now the long one is 77. It's piecewise.
Piecewise
Yes.
function.
Yeah. Are you ready? Let's do it.
Yeah.
So
I remember learning these and thinking they were pretty easy, but they took a while, which
yeah,
is why I'm not excited.
I know. So they made this actually to be kind of doable real fast. I think, at least for this part. But this here, I have to double check where it's going to go. But right now, I can tell that this is the slope of this one. It's a 1/2, but negative 1/2. Do you remember the rise and run? Remember rise and
Yes,
like
yes,
you
yes.
rise 1 and run 2. The denominator will be 2, but if you look at the graph, it's decreasing. It's going down. Therefore, it's negative. So you don't have to worry about, hey, left, where is left, where is right, and being negative, positive. Yeah, we don't
Okay.
have to worry about that. In pre-cal, they will teach you that. You don't have to worry about what negative going where. Just look at the graph from left to right. If it's going down, then it's decreasing. So here, the graph of this one, I'll write it in the slope intercept form because it's linear. All of them actually, each one is linear. So I'll write one at a time and I'll put it together. So from left to right, your first y, I'll do y1, then I'll put it together to make it look like this. You remember? That's the way they want it. Like something, and then the restriction back here. So I'll get to that. Let me do the first equation here. So I can tell it's negative 1/2 x, and the y-intercept, look at this. It's exactly right here. So it's 4 plus 4. Done. Just like that. But you have to restrict it.
Oh,
So let me put it in here. Can you see how I got that?
yeah. Yes.
Yeah. But let me make sure it's, I went over it. So I think it stopped right here, right? I think it stopped right there. Yeah, look at your graph for me. So anyway, that's your first one. You can put it in right now. So it's negative 1/2 x plus 4. But the restriction says you only allow to
It has to stop at 0 and infinite.
could you look at your graph? I can't undo it because I'll undo everything, including my writing.
It
Is this
stops.
close dot?
Yeah,
Yes,
that's where it stops.
and -2, right? Okay, so we're gonna write.
Yeah.
Let me see. I can erase that. No, I can't. So I'll put it. Okay, so it's gonna be x. Okay, this is x. Okay, I'll squeeze over a little bit. Be x. The restriction will be x less than 2, -2, including -2. So that's done. That's done for this
Oh,
one.
okay. Yeah.
Okay, now let's do the one we're scanning from left to right. So we're gonna do this one next. Okay, this one is pretty
I like my
straightforward.
computer, and sorry.
It's okay. So this one is straightforward. Sorry.
Okay.
It's it's y2. Okay, I'll go ahead and isolate these, and then I'll put it in here. So the second y will be x. I know you can tell, just x because plus 0 if you want. You start off with the y-intercept at 0 and then rise 1, run 1, rise 1, run 1. That's why it's just x. 1/1.
Oh,
So it's
okay.
x. See that? So it's just going to be x for the second one. And then the restriction is between -2 and +2. But I have to erase that. I have to erase that brown thing there. Let me see if I can do it. Let me see. I'm going to try. All right, a little bit. I got a little bit. but I gained something else. Okay, it's fine. Oh man. Okay, so it's x, but the restriction is between -2. But the way you write it, it's like this. It's the condensed form is from -2, not including. So you go like this: -2, less than, no bar, x, and then less than or equals to +3. I think, right? It's going up to 3 x wise.
Yes.
Yes, that's it. So it'd be 3 right here. Okay. Now we do the last one. This one right here. This one. This one is the tough one because you have to rise and run it neatly. Okay, I think I'm right. Up 3, run 1. Up 3, run 1. That
Yeah, I
means,
think that's right.
right? So let's see. That means let's try it downward. 1, down 3, 1 over, down 3. Oops, down 3, and 1 over, and down 3.
Okay.
Okay,
Yeah, yeah.
but that means the intercept will be right there. But let me continue. 1 over, down 3. So if I were to connect them, right, it will go like through there all the way down there. You see that? So I hope I'm right on that.
Yeah.
Okay, yeah, double check that. So that means it's fast if you always go by y equals mx plus b. It looks like you can do it for all of them, but that last one is a little tricky. Yeah, because this all of this is actually compressed, the thing that you sent me, because yeah, but it looks good enough. It's pixelated and all that, you know. So okay, that point then,
Yeah.
the y-intercept u b is -5. 1, 2, 3, 4, 5. Yeah, -5. Therefore, your third function is, remember, is up 3, run 1. The numerator, if you up down, is the numerator. So it's 3 over
3.
1. So it's 3. And it's positive because it's increasing. But the y-intercept is negative plus or -5. I believe that is 5. Okay. So count it: 1, 2, 3, 4, 5. Yeah. So that's it. That means the third one, I hope
Wait.
it's right, is this. But then we'll do the restriction. You see that?
Yeah.
Okay. So I hope that's right. The restriction says start from 3 on, including. See right there? 1, 2, 3. I think that's right. 3 on, right? Yeah.
Okay.
Is that point start at 3? Yes. And not including. And not
Yes.
including. So yeah, so it's going to be x greater than 3. That's it. Done.
Yeah, that makes
Okay.
sense. Yeah.
Okay, I'm glad.
Totally makes sense.
Okay. All right. Continue on with the graph. Or you want to look at something else? I'm gonna
Um,
assume that if you
that
get the graph, you'll
I
be able
don't.
to answer these stuff, right? I think you can answer.
That's what I'm guessing. I don't
Yeah, domain and
know.
range.
That
I
one
think you
looks
can.
scary, but like it seems straightforward once I get.
Yeah.
Oh, those are. Oh, it's the parent functions for all the stuff. That's easy.
Okay. So tell me, shall we continue with the graph?
Um, let me check something.
How's this one right here? The 9 to
Uh,
14 ones
I think that's a good one to do.
right here. Okay.
Yeah.
All right. This one, 9 to 14. You use the graph on the side right here on the right to answer 9 to 14. So the notation says f of -2. What that means is that they gave you x as -2 because it's in that f of x notation. Remember? So that's the x position, f of x. Remember that notation? Therefore, -2 is x. So basically, what it's saying is that when your x is -2, when your x is -2, what is your y? So I'll write it this way. When x is -2, what is your y? Because your
Oh,
f of
so this
x,
is the thing. This is the thing where you punch it into the actual like function and then get a solution, right?
yes, but you skim for it. You scan the graph,
Yeah,
look
it's
for
up
it,
to
right?
yeah.
Yes. So
And
are you
then it's
okay
the
the way?
opposite for the one above it. It's like the opposite. Where would that be on the graph, right?
You mean like up here? Oh yeah, let's look at
Yeah.
here. Yeah, this one is
Okay.
also
I don't know. I was
fancy.
just thinking about that.
Yes, yes, that's right. It says what is this is find f of -5. It says find y basically when your x is
Okay.
-5, but your -5 has to be where you have to look for where is -5 in here. You know, so -5 should be the first one. You see that because x is less than
Yeah.
-3, -5 is in there. Therefore, when you want to solve it, you have to use this piece of the function.
Oh yeah,
So
I remember
so you put
that.
in, yeah, you plug it in there, the -5, -5. So two times -5 -5. So it's -10 -5. So the answer should be -15 for number 6.
Okay, I remember how to do this.
Okay.
Yes.
Are you okay? Same thing for this
Yeah, I'm
one.
okay with these. Yeah.
Okay. Yeah, locate where they are. If it's between -3 and 1, the answer is always 4. You don't do any work. Is that okay?
Okay.
Yes. Okay. Okay. What about, are you okay down here then? 4, 7, looking at the
Uh,
graph. Wait, we didn't
well,
answer. We
looking
didn't
at the
answer yet.
graph, the same, basically.
Okay, let's see. Let's try one. Like for example, number 9. Okay, when your x is -2, what is your y? So locate -2 in the graph, like well, on the axis first. How about that? So 1, 2, -2 is right here, but
Mhm.
you cannot use this value because it doesn't exist. You have to
It's
go
not
up here.
actually touching.
Yes, exactly. So -2, that means your y better be here. Is that okay?
Okay.
Okay, it's like, hey, when your x is some value, where's your y on the curve? Exists
So
on the
would it be
curve.
4?
It'll be 4. So the answer would be 4.
Okay. Okay.
So
That makes sense.
okay, let's try another one. Like here, 7. Let's do 7. When your x is 7, so count over 1, 2, 3, 4, 5, 6, 7. Your y is right there. It's -3. Is that okay?
Okay.
I think you got this. Now, but
Yeah.
but then number 12 is the opposite. It's the other way around. It says your f of x is -1. That's your y. Your y is -1. What is your x this time? So you locate the y being -1. Then what is your x? So where's y -1? So like, hey, 1, 2, 3, 4, 5, that to -1, -2, -5. So it's at -1. So not 1, -1, -1, -1 here. So when your y is -1, here's your -1, right? So you kind of go over where the curve exists,
Which means there.
right there.
So it's gonna
The
be
3. You see
3?
that? X is
Okay.
3. You see why though?
Okay.
You want to look at it?
Yeah.
Yeah, it's on the curve. So X is 3. That's it. Okay, domain is it's it's messy. Okay, let's do quickly. The range is also messy. Domain is from -infinity all the way to this right here, -3, not including union from not 3, -2. Is that okay? That's -2. The x value,
Yeah.
-2, and then from -2 including, because it's see it's bold-faced here. Yeah, you don't see it.
Oh,
Yeah, you don't
okay.
see a circle. You don't see a circle. It's inclusive, so it's going to be from
So it's
-2.
the bracket
Yeah, a
or
bracket.
the
Yeah,
whatever the rectangular one
yes,
is.
yeah, it's the bracket. Yes, and then all the way to the +2, close bracket, and then union again, and you go from, see, starting here again, the 2, that +2, but it's not including this time, from 2 to infinity. I know it's
Yeah.
there's a kinks here, but it's still going on. Okay.
But oh yeah 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 yeah
Yeah, it's
yeah.
x. We're looking in terms of x, this way, that way, left, right, x. Yeah,
Yeah.
not y. Now the range is where it's tricky. There are a lot of different cuts, but based on what the teacher, what math is commonly do for this type of graph, piecewise, they basically have you look at, like, looking from the bottom up, and see where all the y exists for all the curves. And you don't have to worry about the cuts in between because it's different than the domain. So all you do is just look at it. So here, let me look at it. So the way I see is that, careful on this one. This arrow points straight down. That means the y exists infinitely in the
Yeah.
in the negative direction. Therefore, it's going to be
Okay.
negative infinity all the way to, if you come up, keep going up, 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 up. This is going to be part of it, so you don't care because it's in here also. The y values is in this piece right here. So you keep going
Mm-hmm.
up, and then what about right there? There's a cut. Nope. This is also inclusive because it's going to be replacing that. Therefore, fine, and then continue, and then it stop at 4. Therefore, negative infinity all the way to 4, and you stop. That's it.
Bracket.
Yep.
Yeah.
And don't worry about the cuts for the range, but you do have to worry about the cuts for the domain. That's it.
What about the parabola in there? Do we not include
Yeah,
that
we
for
did.
the?
We did. If you imagine your y's is there, see the
Oh
y's
yes,
all the
yes,
way up to
yes.
4. There it is. The
Cause
y's,
oh, cause it stops. Yeah,
yeah,
sorry, I
yeah.
thought
The
that
y's
was
in the
for the
curves
section.
stop. Yeah, all the way up 1, 2, 3, 4, 5, including negative. I'm sorry, including the decimal values in there, all of it
Yeah.
up there to 4. The y values. Is that okay? You can put
Yeah.
x, y if you want to note that. Okay, what else? This is
Oh
this it?
wait, is
Is it?
that's it? That's
Okay, this
exactly
is from my
it.
other
Oh my
student, by the way.
god.
So this is from my other student. Okay, all
Okay.
right, have a look. All right, so 324. If you don't know a perfect square number as a factor of that number, which I don't, I actually what I did is that look here. What I did is that I prime factorize it. I half it because I know it's even, so I half it. Punch in the calculator if you need to. So if you do 324 divided by 2, you'll get 162.
Mhm.
And then I continue with that. I divide that by 2. I get 81. So I recognize 81 to be perfect square. You stop. So what happens is that you start
Okay.
writing, gather what you got in here. So that's 4 and then 81 in there. See that?
Hmm.
So what what it means is that 324 is equals to 4 times 81. I didn't know that, by the way. I don't want to memorize every
Oh
single
really?
type of numbers. Every number ever exists. So I hope you're okay how I got that. You prime factorize prime, the only even prime is 2. That means you have to gather them back, times them back to a 4, like that. So anyway, in the
Hmm.
end, once you get to this point, you should be able to actually put this back into the root. When you put it back in the root, it's a 4 and 81. A 4 is a perfect square. 81 is a perfect square. Therefore, a root of 4 is 2. A root of 81 is 9. That's how I got these. And then you multiply them, 18. Now, if you punch
Okay.
this in the
Yeah, makes
calculator,
sense.
if you're allowed to use a calculator, you punch in the root of 324, it will give you 18.
And
Oh, just like that,
oh,
even. But it will not work for
oh.
it will not work for number 19. You see why? Because you have a root 6 left. Okay, look at 19 if you want to see it. That 18 is actually a perfect square number. 324 is a perfect square number, but 19 is not.
Mm.
One 150 is not a perfect square, so we break them up quickly here. Say I break it up in halves again,
Yeah.
75, and I bubble. I should have bubbled the prime, any number in the front, all the prime numbers. So 75, I know it's 3 times 25. So I bubble that. Then I come across the perfect square number, which is 25. Now I stop. Then I start going back, putting everything back in. You can multiply 2 and 3, but you don't need to. You do it later. But 25 is there. Now, then you look at what you gathered. You cannot actually square root the 6, but you can square root the 25. That's what it is outside. That's 20. That's 5.
Okay.
But then whatever you cannot square root, you just keep them in the root.
Okay.
So is that okay? All right. I hope you're okay with this one.
Yep.
169 is 13 times 13, but a root of a negative is I. Remember that? So there.
Okay.
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 Now,
Yeah.
what about these ones? What about the one that raised to
Those
the?
I vaguely remember. I have notes on them still, but
Okay.
I just remember it's like one, two, three, four.
Okay.
The first one's just one. The second
Okay.
one's like negative I, then negative
Yes.
one,
So
then
let's memorize this.
some
This is what you need to make sure you have. So you're only allowed to write I, which is a root of a negative. Then I, but don't write I squared. But if you come across I squared, it's 1. You're allowed to write 1. But when you come across I to the third, I'll show you how you would come across that in a second here. Watch, I'll do it again. When you come across I to the third, you write negative I. You're only allowed to write negative I, 1, and I. But then when you come across I to the fourth, you're only allowed to write 1. Oh, negative 1. Oh, sorry. I squared is negative 1. Sorry, careful. Go back.
Oh,
I squared is negative 1. I to the fourth is positive 1. Okay.
okay.
Okay, memorize this because you need it to go fast. Okay, how do you actually use them? You do long division for the exponent every single time. So watch So I watch how I did it. I divide the exponent, the I exponent, by 4. The answer is your denominator. Oh, one additional 1. I to the 0 power is also 1. Is that okay? Anything to the 0 power is 1. So be ready to. I to the 0, anything I to the 0 power is 1. So anyway, once you do long division, your denominator is basically almost the answer. You write I, you write I to to that denominator. That's the answer. I to a big number, I to a very high value, to a very high power, will always be equals to I to some power between
Okay.
between 1 and 4. But you have to do long division. So anyway, one more time. One more time. Take the 99 divided by 4. Don't look at the quotient. Don't look at the answer. Look at the denominator.
And
What do you do with the
whatever
denominator?
your
Yeah,
remainder.
you write I to that denominator. But then you have to
Okay.
go, then you have to come here to see what the final answer is. Is that
Okay, I
okay?
remember this. This makes
Yeah.
sense.
Yes.
Yeah, I got that.
So I to the third is there. It is your negative I. So I did the 20. I'm sorry. I did the 33 one. So I divide that by 4. I don't care about the 8, but I only look at the denominator. Then I write I to the first power. But I to the first power is just I. That's why you. That's why the answer is just I. Oh, here it is. Is that okay? Yeah.
Yes.
Yeah. Put the denominator in as the exponent of the I. So I did this one. 252, I divide that by 4, it's even. It come out 0, but I still write it I to the 0 power. Anything to the 0 power is 1, so the answer is 1. Done. That's it. So imaginary, this type of numbers that raise to a higher power is basically you just divide it by 4. The denominator you gather, you put it back into the I, I to that denominator, and then evaluate. That's it.